But next up, Tyrone's finest, Laura Kelly, going to talk to us about rebuilding the car while the customer is driving. Laura, everybody.
Hi folks, everybody hear me okay? Perfect. As Danielle said, my name's Laura and I am from Tyrone, so it will be the car that the customer's driving. I'm a software engineer at Rapid7 and today I'm going to talk a little bit about rebuilding the car while the customer is driving. Before I get into the nitty-gritty technical stuff of this, I want to chat a little bit about why this topic specifically. So for anybody who isn't aware or maybe has forgotten or was maybe away on holiday when this happened, 2024 July, there was the massive CrowdStrike outage. Now, this happened to be one of the world's largest IT outages in history, to the degree that even my granda, who thinks that the internet is for football results and death notices, was actually still talking to me about this and he's going, what's going on with this? So in essence, in the 19th of July 2024, CrowdStrike rolled out an update to its Falcon software. This update managed to cause over 8.5 million systems worldwide to crash. They were unable to restart and they all had the dreaded blue screen of death. And this was all down to one single update. Now, in the weeks following, CrowdStrike released their analysis on this and it turned out they were using an array that was to help parse a file. And in essence, they expected there to be 20 elements in the array and there were 21. It seems pretty fundamental, something you should have been checking during testing. And when you read further into the report, it turns out that CrowdStrike in their unit tests had only happy path tested their code. In their regression tests, they only used valid data sets. They had no sandbox or staging environment that was representative of what customers were actually using. And they had no staged rollouts. You know, it kind of went out to all customers at once. And this affected airline industry, it affected financial institutions, emergency services, governments. It cost billions and billions of dollars in damages to different companies throughout the world and even to the UK economy. There was over £2.5 billion worth of damage done to this. And you can kind of say, okay, this is simple. It was a fault with an array, but that's not quite representative. It was actually a systemic SDLC complacency, SDLC being software development lifecycle. And I know we chatted about this in work and our first reaction was, thank goodness it wasn't us. And I say us in terms of, yes, Rapid7, because like CrowdStrike are our competitors, so I'll not talk too badly about them. But us as well in terms of us as engineers. I work on a back-end cloud team. I could just as easily worked on Rapid7 equivalent of their Falcon software, our agent, and that terrified me. It is such an easy mistake to make. And the reason this also terrified me was because my team was in the very early stages of a very significant rearchitecture project. So we were in the process of moving from using AWS EMR to using Iceberg for our data sources. We were changing from using Presto to using Trino as like as a data layer. We were in the middle of an EKS migration, so we were moving away from EC2. There was, Yes, there was completely new ingestion pipeline. So we were transforming data differently. We were doing a new data-centric approach across the company. And there were massive query changes involved in this. This was a really, really substantial project that was taking about 20 engineers well over 3 months. And suddenly the CrowdStrike outage happens and we were all scared. There was no pressure in any of this, right? I think it's important to recognize there was a lot of pressure in this, actually. And this was the biggest project that I, as a junior engineer, have been involved with to date. So I definitely was feeling a bit afraid about all this. So in saying that, whenever I was an intern at Rapid7, there was a presentation with the same title as mine. I shamelessly stole it, I'm not gonna lie. And this notion of rebuilding the car when the customer's driving was an analogy to kind of describe the risk that we as engineers face when we make any changes. All the changes we make are done with the best of good intentions. You're fixing a customer problem, you're making the product cheaper, you're making it faster, but the road to hell was paved with good intentions. It's the same today if you go to the hospital with pain in your side and the doctor tells you you have to get your appendix out. Pretty routine operation, but there's risk involved with that. You're trusting that your medical team and at the hospital have done their due diligence to make sure that everybody's well trained, they're qualified, they've looked at your medical history to make sure you're not going to have any adverse reactions. Our customers place the same trust in us to make sure that we do our due diligence, that we're testing, that we've tried to mitigate as much risk as possible when we're making our changes. And the trust that their customers placed in CrowdStrike, it kind of was misplaced when you see that the systemic SDLC failures that they had in that outage. So it kind of felt a little bit like this. It felt like we were driving along, changing tires. It was scary, it was risky. And so we kind of took a step back and go, okay, well, what can we do to try and mitigate our risk? So, this is all about cars. So we decided to create a roadmap. I promise it'll be the last bad joke I tell today. So these were the questions that we come up with to ask ourselves when we were developing this project. How can we mitigate as much risk as possible? So it was, where am I? How did I get here? Where do I want to go? How do I get there? And how will I know when I'm there? I'm well aware of the fact that sounds like the ramblings of a very confused woman. I have been known to ramble, and I've also been known to be a confused woman, so that's pretty accurate. So I'm going to talk through each of these questions. I'll describe what we kind of thought about and what we discussed in terms of each of the questions and where we were in terms of the project and how we answered them. So we'll start off with, where am I? So it's a pretty good thing today that everybody has managed to get here. You've all managed to come from wherever you are in the world to Belfast. Well done. That's a very easy thing to do when you know where you started off with. If I took you blindfolded out of this room today, left you on a rural back road somewhere and asked you to make it back here, that's a pretty difficult thing to do if you don't know where you are. There's a quote by Maya Angelou. I love a good quote. That's, you can't really know where you're going until you know where you've been. That's more actually as well where you are. Defining the route between A and B is very difficult if you don't know what A is. So this thorough understanding of where you are right now is fundamental to what you want to do with any project. The biggest risk to any kind of engineering change or any massive re-architecture project like we were doing was assuming you know where you are when in reality is very, very different. So the things like thorough documentation. Is it a documentation that your company has, if you have any at all? Is it up to date? Is it accurate? Do you have architecture diagrams and data flow models that accurately represent your current system? Is there anything that has changed recently or anything that has, maybe is putting your project at risk? And this was one of the big things that we actually had to take a lot of time and figure out. Because in the stages of figuring out where exactly we are right now, me and my team, we managed to uncover a lot of very scary skeletons in the cupboard that would have put our project massively at risk. So in terms of where were we had an overly complicated, outdated, difficult to maintain architecture that was not efficient at scale. And I'm going to guess this is the same for most companies. You're probably working on code that's 5, 10, 15 years old, if not older. And the capabilities that they had then are not the capabilities we have now. So understanding what we had before we decided to rip it up and change it was fundamental moving forward. And kind of related to that is the how did I get here? And I think it's the whole thing about those who ignore this, history's mistakes are doomed to repeat them. That's really, really applicable to software engineering. We have this tendency to look to what do we have and what do we want? What's in the future? But we never really recognize how we actually got there. Nobody really enjoys technical archaeology, figuring out the mysteries left in the code by our ancestors that worked here 5 years ago. But it's really actually important, because if you don't understand why certain decisions were made, you're really at risk then of making the same wrong decisions that maybe people in the past have made. And this is true for the most part. I'm not going to say it's true for everybody, but for the most part, the people who wrote the code you're working on now were intelligent people. And they made the best decisions that they could make at that time. But that doesn't mean it's the best decision for right now. But you have to figure out why. If you're at a fork in the road and there's a sign that says Belfast 10 miles one way, Belfast 30 miles the other way, and all the traffic's going the 30-mile road, you kind of have to wonder why. Is it a safer road? Are there less potholes? Is there roadworks on the other road? You kind of have to wonder why you're taking what now looks like a really weird, stupid route. But in the past, it may have actually been quite sensible. So how did we get to where we were? Previous engineers had done their best with the time, resources, and technological capabilities that they had. They produced a cost-effective solution at the scale of the company was at the time of the product's creation. Their solution was then shoehorned into loads of different applications due to time pressures, leaving us with this spaghetti mess of an architecture. The code you write as a startup is not the code that you write 20 years in the future. And we have to recognize that people who wrote the code then, they maybe would write different code now. So we know where we are, we know how we got here. Now let's think about the future. Let's think about where do we want to go. And here's things to think about when you're deciding your destination. I don't know if anybody else here has had the thing, when they're at home and I don't know what I want to eat. What do you want to eat? I don't know what I want to eat. What do you want to eat? You have to decide where you're going before you can think about actually getting in the car and going anywhere. So you need to think about what will your new system look like? And what's actually motivating this change? There has to be something motivating it. Do you want it to be cheaper? Is it faster? Is it difficult to maintain? Are you trying to get some kind of compliance certification? Is it something that, you know, you're moving from one cloud provider to another? These are the questions that are motivating the changes. So they're going to be the answers to, okay, what's the new system going to look like? And you also have to think about what resources do you have to undertake the change? I don't know about you, I would love to go on a 3-month holiday around the world, 5-star, all-inclusive, but my resources and my money will not necessarily allow that. So you have to think about what resources do your company and do your team, what skills, what amount of people do you have right now, and that's going to affect what your new system's going to look like. So where did we want to go? So I've already said what we were trying to change, and ultimately what we wanted, in essence, was a maintainable, scalable, and cost-effective solution that was faster than what we already had. And that really informed then, okay, well, what do we want to do? The next thing we want to see is, how do we want to get there? So it's easy for me to say that I want to go to McDonald's, I have to plan out the right route. It's easy for me to say I want to go to Dublin, I have to plan out the right route. And it's important to know as well, all roads lead to Rome. They also lead to Culloden if you try hard enough. I love a good quote. This one happens to be from my mother, actually. You know, if I asked you today from drive from Belfast to Dublin, you could go via Cork. I'm not sure why you would want to, but you could. Just because you can go a certain road doesn't mean you should go that road. So it's important to plan out what steps are you going to take in order to reach your goals. And these are things to think about when actually planning what route you want to take. Can you make and deploy these changes incrementally? Can you make tiny little steps that you can verify at each stage, rather than this being a massive rollout that's then such a shock to the system? Can you test the changes in a sandbox or staging environment? And more importantly, in a sandbox and staging environment that's representative of what your customers are using. If your staging environment has 2 customers and it has about 5 gig of data, when your customers, there's thousands of them, and they're dealing in petabytes of data, your sandbox environment may as well not be there. Do you have comprehensive data sets to test your changes against? This is somewhere where CrowdStrike fell down. They only tested against valid data sets. They didn't see what would happen if you gave their product garbage, what would it do with it? And it decided it wanted to panic. Can you have both systems running in parallel with a gradual rollout? You know, can you maybe have one customer move at a time, validate their data, and then, okay, we want maybe 5% of customers go across, 10% of customers, so you can have that confidence rather than saying, right, you're getting this whether you like it or not, and it's broken. Wait, oh. So that gradual rollout can be a massive confidence builder. And do you have enough resources to get there in a sensible timeline? Again, as engineers, we maybe argue about what a sensible timeline is at times, but if I asked you to get from Belfast to Dublin today in 2 hours, okay, the sensible thing to do is to take a car. You could walk, if that's the only resources you have. If you don't have a car, you could walk it, but you're not going to get there in a sensible timeline. So being realistic about what resources you have right now in terms of planning your route out for the future is really, really important when planning this route. Lauren touched on this earlier on, testing. You have to test your changes. And there's so many different types of testing you could do. There's unit and integration testing with lots of different types of data, not just happy path testing. There's the regression testing where, you know, I'm giving the exact same data to what I currently have and what I want customers to have. Does it give me the same thing? Should it give me the same thing? If there's differences in the results, are they differences that you expect? Are they differences that you potentially want? If not, there's a pretty good indication that you can't roll this out right now. And blue-green deployments as well. Can you, again, have both these systems running in parallel with a small percentage of traffic going to your newer system? If so, then yes, you can promote it. If not, it's really easy to roll it back then. You want to set yourself up for success and do this in a way that's manageable, and a way that if something does go wrong, because things inevitably do go wrong, that you can roll back quickly and recover. So how did we get to where we want to go? We had many planning sessions to properly plot out our route. We tested against every single data set we could imagine. We collaborated with multiple external teams, QE teams, testing, whatever it may be, to conduct additional rounds of testing. We pulled in engineers from all our teams temporarily because of their knowledge, because of their expertise, to try and set us up for success as possible there. And we worked like mad to reach our destination. It felt like running a marathon at times, in fairness. And the last question then is, how will I know when I'm there? If you decide to plan out your route, in fact today I was using Google Maps to come here, and I put in Ulster University and it led me to a side street, and I'm like, am I in the right place? It's important to actually recognise make sure you can recognise, am I in the right place now that I've done all this work? It can be confusing at times. Sometimes it's easy. Sometimes it's easy to look out the car window and say, oh yeah, I've reached the beach. This is where I wanted to go. Brilliant. Other times, maybe not necessarily. So how will I know when I'm there? Part of defining your clear goals whenever you're deciding your destination, this should include clear conditions of satisfaction. If the motivating factor for this change is I want my product to be faster, well then great. You'll know when you've got there, when you've rolled out your changes, and you can say, right, previously this took 5 seconds to do, now it takes 1 second. Great, we've got where we wanted to be. Things like test results, monitoring metrics. I'm going to make a little plug into my last year's talk about making sure you're monitoring your stuff. Measurable analysis. These are all things that are going to help you recognize that you've actually gotten where you want to be. And I think that's something that we don't necessarily think about a lot of the time is, was this actually successful? And you know, if the system works and it's better than before, you've probably got where you want to go. It's a pretty good indication that you've got where you wanted to go. But actually been taking a step back and recognizing, okay, we've got here, this is all good, everything's fine. You know, that's really important in making sure that your project is a success. How did we know that we had gotten there? I'll let you know when we get there. The project's still underway. We're still in the process of rolling it out. We're still in the process of finding problems and saying, okay, we can't roll this out to customers yet. Let's fix it, make sure we have tickets for it. We have clear conditions of satisfaction that we want to make sure that we have satisfied by the end of this, and we haven't satisfied them all yet. But we know when we get there. We're just not there quite yet. So just a little quick recap on our roadmap. It's kind of like, you know, looking back on all the photos of your road trip that you've been on. So you want to know, where am I? How did I get here? Where do I want to go? How do I get there? And how will I know I'm there? And it's a pretty good indication that you're doing things right if the customer's still driving along the road and along the right road whenever you're finished. Any questions?
Thanks. Are there any questions? Again, scanning the room.
We're a very shy group today.
I'll ask.
Go for it.
With the questions you asked, in hindsight, did you get any of the answers wrong at the start?
Absolutely. 1,000% yes. When we started out this project, we were not going to be using Iceberg. We were not going to be using Trino. The initial purpose of this project was just to keep EMR, but make it a lot better than it was. And in asking those questions, and as we started to plan things out and do our initial proof of concept, we figured this was not going to work. And we kind of had, you know, you're driving down the wrong road. There's a road close sign in front of you, and like, okay, I got to do a U-turn here, go back on myself a little bit and take a better route. So absolutely, we found that we were going about it the wrong way initially, yes.
Fair play. Thank you again, Laura.